Welcome to JS Production. So today we are going to be looking at organic chemistry. We'll be looking at organic chemistry. If you are new to this channel, make sure you subscribe and turn on the notification bell so that each time I post a new video, you might be notified. So we are going to start with the definition of organic chemistry. So what's organic chemistry? Organic chemistry is defined as the study of carbon-containing compounds. So it is defined as the study of carbon-containing compounds, and I'm going to write down that definition on my whiteboard. So I've said organic chemistry is the study of carbon containing compounds. So that's the definition, and we have different types of organic compounds. And the moment you hear the name of the organic compound, it must tell you two things. So it must tell you the family to which it belongs to. It must also tell you the carbon atoms that are found in it. So every time you hear the name of the organic compound, it must tell you two things: the family and the number of carbon atoms. So I've said each time you hear the name of the organic compound, so the name of the organic compound, it will tell you two things. It will tell you the family to which it belongs to. It's also going to tell you the number of carbon atoms in it. So number of carbon atoms. So we have different types of organic compounds. So for example, if you hear the names like methane, ethane, ethene, propene, ethanol, propanol, ethanoic acid, propanoic acid, you must know the number of carbon atoms that are in these compounds or the families to which they belong to. So there are different types of families. So let us look at the families. So for the families, we have different types. The first family that we have the alkanes. Apart from the alkanes, we have the alkenes. We also have the alcohols. We also have the carboxylic acids. So if you hear the name of the organic compound, the compound is going to belong to one of these families. So we have the alkanes, the alkenes, the alcohols, and the carboxylic acids. So let us proceed. So if the name ends with, so if the name ends with the first situation that I'm going to give, if it ends with A-N-E, that means it belongs to which family? So here I'm going to put family. So if the name ends with A-N-E, that's the name of the organic compound. That means it belongs to the alkanes. It belongs to the alkanes, and an example that I'm going to give here, is ethane. And the formula of ethane is C2 H6. So each time you come across the name of the organic compound that ends with A-N-E, that means it belongs to the family of the alkanes. And an example that I've given is ethane. Then another situation, if the name ends with E-N-E, that means it belongs to the family of the alkenes. That means it belongs to the family of the alkenes. So as you can see, we have E-N-E there. Then an example that I'm going to give is ethene. And the formula of ethene is C2H4. So each and every time you come across the name of the organic compound and the name ends with E-N-E, that means it belongs to the alkenes. And an example that I've just given is ethene, and the formula is C2H4. So let us proceed. So if the name ends with another situation, if the name ends with OL, that means it belongs to the family of the alcohols. It belongs to the family of the alcohols, and an example that I'm going to give is ethanoic acid. It's ethanol, sorry. It's ethanol. That's an example that I'm going to give on the alcohols, ethanol, and the formula of ethanol is C2H5OH. Then if the name ends with OIC and an acid, that means it belongs to the family of the carboxylic acids. It belongs to the carboxylic acids, and an example that I'm going to give here is ethanoic acid. And the formula of ethanoic acid is CH3COOH. So this is how you identify the family to which an organic compound belongs. Let us now look at on how you can identify the number of carbon atoms that are in the name of the organic compound. So if the name starts with meth, so I'm going to write if the name starts with, so the first situation, if it starts with meth, that means it has how many carbon atoms? That means it has 1 carbon atoms. So here I'm going to write number of carbon atoms, and I'm going to give some examples from the alkanes. So examples from the alkanes. And the general formula of the alkanes is written in this form: C2H2N plus 2. So this is the general formula. So if the name starts with meth, that means that the organic compound has 1 carbon atom, and writing the formula of an alkane there. So this is going to be methane And the formula of methane is CH4. So if we get our 1 here, we replace where there is N. So if we put 1 where there is C here, if we put 1, so that's going to be C. Then if we put our 1 there, it's going to be 2 multiplied by 1. Then 2 multiplied by 1, that's 2 plus 2, that's 4. So the general formula of the alkanes is CnH2n plus 2. So let us look at another situation. If the name starts with eth, that means that the organic compound has 2 carbon atoms. And an example from the alkanes I can give, that's going to be ethane. And the formula of ethane is C2H6. Also, if the name starts with prop, that means that the number of carbon atoms that are in that organic compound is 3. And an example from the alkanes, this is going to be propane. And the formula of propane is C3H8. Let us look at another situation. If the name starts with but, that means it has how many carbon atoms? That means it has 4 carbon atoms. And an example from the alkanes, that's going to be butane. And the formula is going to be C4H10. Another situation, if the name starts with pent, the number of carbon atoms that are going to be in that organic compound is 5. And an example from the alkanes there, this is going to be pentane. And the formula of pentane is C5H12. Another situation, if the name ends with hex, that means that the number of carbon atoms that are in that organic compound is 6. An example from the alkanes, that's going to be hexane. The formula there is going to be C6H14. So this is how you identify the number of carbon atoms that can be found in the organic compound. So let us compare the different families. Since we have said that we have different families, we have the alkanes, we have the alkenes, we have the carboxylic acids and the alcohols. So let us compare these different families. So we are going to make the comparison. So comparing different families. And the first family that we're going to start with are the alkanes. And from the alkanes, an example that I'm going to give here, an example of an organic compound from the alkanes that I'm going to give is ethane. Ethane, and the formula of ethane there, the formula is C2H6. That's the formula. And if we write the structure formula of ethane, it's going to be in this form. So structure formula, it's going to be in this form, C and a C, but you must note that each C here, it must be connected to 4 bonds. So I'm going to have another bond, another bond, another bond. So if I count how many bonds I have, 1, 2, 3, 4. So I can put my hydrogen atoms. Also, these carbon atoms must have 4 bonds. So I have 1, 2, 3, 4, and I'm going to put my hydrogen atoms there. So that's the structure formula. So if we look at the formula here, it says C2. Let us count the number of carbon atoms. So we have 1, 2, so that's correct. Then let us count the number of hydrogen atoms. So we have 6 hydrogen atoms from the formula. And if we look at the structure formula, how many hydrogen atoms do we have? Let us count 1, 2, 3, 4, 5, 6. So that's correct. Then let us look at the characteristics. Characteristics of these alkanes. So the first characteristics is that these are hydrocarbons. And the reason why the alkenes are hydrocarbons is because they only contain hydrogen and oxygen atoms. So if we check the structure formula of ethane there, we only have carbon and hydrogen atoms. That's why they are referred to as hydrocarbons. So hydrocarbons are compounds that only contain hydrogen and carbon atoms. Then the other characteristic that we can give is that the carbon-carbon bond that forms the alkanes is that of a single bond. So the carbon-carbon, as you can see here, this is just a single bond. So the carbon-carbon bonds that form the alkanes is of single bond. Is of single bond. Then the other characteristic that we can give here is that these are saturated hydrocarbons. And the reason why they are saturated hydrocarbons is because they are made up of a carbon-carbon single bond. So these are saturated hydrocarbons. So let us continue comparing the different families. And the families that we are comparing, I've said we are comparing the alkanes, the alkenes, the alcohols, and the carboxylic acids. We are just done the alkanes. So now we are going to look at the alkenes. And an example from the alkenes that I'm going to give you is ethene. So I'm going to use ethene. An example here, I'll use ethene. And the formula of ethene, here is C2H4. And let us write the structure formula. For the structure formula, I said that each carbon atom must be connected to 4 bonds. But on the alkenes are made up of double bond. So here there's no single bond. They're made up of double bond. So as you can see, this carbon atom, it has how many bonds? It has 1, 2. So for this to have 4 bonds, that means I only need to add the extra 2 bonds. So I'm going to put 1 here and 1 there. That same applies to this carbon atom. So I'm going to put another bond here and another bond, and I'll put my hydrogen atoms. So this is how you write the structure formula of ethene. Then let us look at the characteristics. So the first characteristic that we can say here is that the alkenes are hydrocarbons. As you can see, they only have carbon and hydrogen atoms, so these are hydrocarbons. Then the other characteristics that we can say is that the alkenes are made up of a carbon-carbon double bond. So they are made up of a carbon-carbon double bond. Then the carbon-carbon double bond, that's the functional group. So the carbon-carbon double bond is in this form. So this part here, this is the carbon-carbon double bond. So which is written in this form. And this carbon-carbon double bond, that's the functional group. So the carbon-carbon double bond is the functional group. And the functional group is just the part of the molecule that largely detects how the molecule reacts. So this is just the part of a molecule that largely detects how a molecule reacts. And for example, if we look at the alkenes, they undergo hydrogenation to form the alkanes. So all the alkenes, if they undergo hydrogenation, they'll be able to produce the alkanes, and the only reason why they are able to produce the alkanes because they have the functional group. So the functional group is the part of the molecule that largely detects how the molecule reacts. Let us look at another family, which are the alcohols. And from the alcohols, an example that I'm going to give is ethanol. So example is ethanol. And the formula of ethanol. The formula of ethanol is written in this form: C2H5OH. And the structure formula there we can say so that's the structure formula. Let us now look at the characteristics. So the first characteristic that we can say there is that the alcohols are like the alkanes, but the only difference is that they only contain the OH group. So the alcohols are like the alkanes, but they only contain the OH group. So you can say they only contain the OH group. Then the other characteristic that we can give there is that the OH group, that's the functional group of the alcohols. So the OH group that's the functional group of the alcohols. Then all alcohols have the OH group, so they contain the OH group. And let us look at the carboxylic acids. An example that I'm going to give on the carboxylic acid is ethanoic acid. So example here, ethanoic acid, and the formula of ethanoic acid is written in this form: CH3COOH. Then the structure formula. So our structure formula there to be in this form. So I have the first carbon atom will be connected to 3 hydrogen atoms. Then I have another bond there that will connect this carbon atom. Then I have the double bond on the carbon, and it will be connected to the oxygen atom. Then I also have another bond that is going to connect to the OH, there. So that's the structure formula of ethanoic acid. And let us look at the characteristics. So the first characteristic there that we can mention is that the carboxylic acids are not hydrocarbons. And the reason why they are not hydrocarbons, if we check at the structure formula of ethanoic acid here, we see that we have hydrogen atoms, we have carbon atoms, and oxygen atoms. So there is oxygen atoms here. So these are not hydrocarbons. So not hydrocarbons. And these carboxylic acids, they contain the COOH group. So they contain the COOH group, and the COOH group forms the functional group. So the COOH group, that's the functional group. So that's all about our lesson today. I hope you have enjoyed, and if you have not yet subscribed to my YouTube channel, make sure you subscribe and share this video with your friends. I'm also going to inform you that we offer online tuitions, and the tuitions that we offer, the subjects include physics, chemistry, math, and biology. And the price is only 100 kwacha per subject. So for further information, you can call me or text me on the number which is 0973023620. And the other thing that we provide is that we sell some past papers with answers. So if you want the past papers with answers, you can also text us on the same number. We also sell some books, both hard copy and soft copy. If you need those books, you can also text us on WhatsApp. Then, if you want to donate anything to this YouTube channel, if you want to help this YouTube channel grow, or you see that these videos, they actually help you, and you also want to help us, you can actually donate the funds in these mobile numbers. For Airtel, you can use 0973023620, and for MTN, you can use 0968629310. That's all from the production crew, and today the cameraman was Mr. Gabriel Tamba. We shall meet you next time. Peace. So at Just Production, we provide the following services. We sell some past papers with answers. And the past papers that we have 2017, 2018, 2019, and 2020. And these past papers, you can get them at both hard copy and soft copy. For the soft copies, they are only going at 20 kwacha per paper. So that means if you want paper 1 for 2020, you just pay a 20 kwacha. And after you pay 20 kwacha using Airtel or MTN mobile money, we are going to send it on WhatsApp. Then if you want a hard copy, it is free delivery within Mandef constituency, or we can deliver in town, we can meet in town, and I can give you that hard copy. Then the other service that we provide are Just Productions, that we provide online tuitions. And for the online tuitions, we provide subjects like physics, chemistry, math, and biology. and the price is only 100 kwacha per subject. And for instance, if you want to be learning mathematics, you just pay 100 kwacha and you are going to be added to a WhatsApp group. And in those WhatsApp group, we actually post videos on a particular topic, and where you have questions, you can ask in the group. So that's how the online tuitions work. So it's 100 kwacha per month, and that's per subject. Then we also sell some books. We sell books for all the grades from grade 10 to grade 12, and these books include for physics, chemistry, math, and biology. And the price is only 10 kwacha per subject, and that's soft copy. And for the hard copies, it's only 25 kwacha. So for further information, you can call me or text me on the number that is showing on the screen, which is 0973023620. Peace. God bless you. The full topic of current electricity is available, and it's only going for sale at 10 kwacha. And after you make a payment using Airtel or MTN mobile money, I'm going to send the video on WhatsApp, and this video includes the following: electrical symbols, current, quantity of charge, direction of current, potential difference, electromotive force, electrical energy, power, electrical resistance, the circuit, series connection, parallel connection, cost of electricity, the 3-pin plug, the fuse.